Welcome to the deep dive.
Right.
So forget your usual software, the kind that just sits there waiting for you to click go. Today, we're diving into agents. It's kind of a new category of AI systems. They're powered by large language models, LLMs. Think of them as having the smarts to handle pretty complex, multi-step tasks all on their own, really acting independently to get things done for you.
Exactly. And this isn't just, a simple chatbot giving you a quick answer or like a tool that tells you if a comment is positive or negative. That's basic stuff.
Right.
What really sets agents apart is their ability to manage a whole process and make decisions along the way to reach a goal you've set.
Okay.
So imagine an AI that doesn't just answer a customer service question, but actually resolves the entire issue, start to finish.
Wow.
Or maybe one that can plan and book a whole trip without you having to micromanage every single step.
Okay, so it's definitely not just about following one command. What are the key ingredients then? What makes up one of these autonomous agents, like the must-haves?
Yeah, good question. There are basically three core things that define an agent. First, right at the heart, there's an LLM. That's the decision-making engine.
The brain.
Exactly, the brain. It figures out the steps in a workflow, manages how it gets done, and that includes knowing when a task is actually complete, and even being able to backtrack or maybe try a different approach if something goes wrong, like a smart assistant that can, adjust its strategy on the fly.
So it's more than just reading off a script then?
Precisely. The second key thing is the ability to access and dynamically select from a range of external tools.
Tools.
Yeah, tools. These let the agent interact with the outside world. So searching the web for info, accessing databases, maybe even using other software. It chooses the right tool for the right stage of the task.
Okay.
All within boundaries that we've set. And that brings us to number 3. Operating within defined guardrails.
Guardrails. Okay, that sounds really important. We should definitely circle back to those later.
Absolutely.
But before we do, when is building an agent actually the right move? I mean, it feels like it might be a bit overkill for simpler automation tasks.
You've hit on a really critical point there. Agents are particularly valuable where, let's say, traditional automation kind of falls short.
Like where?
Think about workflows needing a lot of nuanced judgment calls, where the rules aren't just black and white, maybe they even change frequently. That makes rule-based systems a real headache to maintain.
Right, constantly updating them.
Exactly. And also, if you're dealing with loads of unstructured information, text and emails, documents, that's another place where agents can seriously shine.
You mentioned payment fraud earlier. Was that an example?
Yes, perfect illustration. A traditional fraud system, the rule-based kind, it's like a very strict checklist. Flag transactions that hit specific predefined criteria. Bam, bam, bam. An agent with an LLM, though, it can act more like an experienced fraud investigator. It looks at the bigger picture, notices subtle patterns maybe a rule wouldn't catch.
More intuition, almost.
Kind of, yeah. It can spot potentially dodgy activity even in ambiguous situations. That ability to reason in complex, less clear-cut scenarios, that's where agents really excel. If your workflow is more straightforward, deterministic, then yeah, assembly automation is probably better.
It makes a lot of sense. Okay, so we're talking about these new independent problem solvers. Now let's get down to it. What do you actually need to build on? What are the fundamental components?
Right. Think of building an agent, like building a robot. You need a brain that's the model, the LLM giving the reasoning power.
Got it.
You need hands to interact with the world. Those are the tools, the external capabilities the agent uses.
Okay.
And you need a set of instructions and safety guidelines. That's the instructions and guardrails. Tells the robot what to do, how to do it safely.
Okay, let's start with the brain, the model. There are so many LLMs out there now. I mean, where do you even start choosing the right one?
Choosing a model, yeah, it involves balancing a few key things. How capable it is, understanding and reasoning, how fast it responds, that's latency, and of course the cost.
Right, cost is always a factor.
And what's interesting is you might not actually need the most powerful, most expensive model for every single task in a bigger workflow.
Oh, okay.
Yeah. Simpler steps, maybe just grabbing information or figuring out what a user wants, those might be handled perfectly well by a smaller, faster, cheaper model.
That's a really good point. You don't always need the sledgehammer. So what's a good strategy for approaching this selection then?
A pretty effective way to go is to start by building your first version, your prototype, using the most capable model you can get for all the tasks.
Set the bar high?
Exactly. That gives you a benchmark, shows you the best possible performance you could achieve. Then, once you have that baseline, you start experimenting. You swap in smaller models for specific tasks. See if they still meet your accuracy needs. This way, you're not limiting yourself from the get-go, and you get a clear picture of where smaller models are good enough and where you really need the big guns.
Makes sense.
And crucially, you absolutely need to set up evaluations. People often call them evals.
Evils?
Yeah, evals. To get objective measurements of how each model performs in your specific situation. Looking at accuracy, speed, maybe how it handles weird edge cases.
Got it. Establish the best performance, then optimize down for cost and speed where you can, using those evals. Okay. Now let's talk about giving our agent those hands, the tools. How do you equip it to interact with the real world?
Tools are basically how an agent does more than just, process language.
Sure.
They let it interact with external systems, usually through APIs, application programming interfaces.
Right. The standard way software talks to other software.
Exactly. Think of an API like a digital doorway.
Yeah.
And even for older systems, legacy stuff that doesn't have those nice APIs, we're seeing these computer use models emerge. They can interact with websites and apps almost like a human would click around.
Wow. Okay. So if an agent needs to look up a customer's info in a CRM system, that lookup action would be a tool.
Precisely. And it's really important that each tool has a clear, standardized description. Makes them easier to reuse across different agents, simplifies managing them later, like having a well-organized toolbox properly labeled.
Makes sense.
Broadly, we can put tools into three main buckets. First, data tools retrieving info. Querying databases, reading documents, web search, that kind of thing.
Okay.
Second, action tools. These let the agent do things. Sending emails, updating records, maybe handing off a support ticket to a human.
Right. Taking action.
And the third category is orchestration. This is where agents themselves can act as tools for other agents. It's a fascinating concept. We can definitely dig into that more when we talk multi-agent systems.
Agents using other agents as tools.
Yeah.
Yeah, it sounds pretty advanced. We'll definitely need to circle back. You mentioned the Agents SDK earlier. Can you give us a quick, code example snippet of equipping an agent with tools using that?
Absolutely. Let's say you're building an agent and needs to research topics online, then save the key finding somewhere.
Okay.
Using the Agents SDK in Python, you could define one tool using a built-in web search tool for the searching part. Then you might write your own function, say save results, and define that as another tool. It takes the search output and saves it maybe to a database.
So you mix and match pre-built and custom tools.
Exactly. When you set up your agent, you just tell it, here are the tools you have access to. And just a side note, as the number of tools an agent needs grows, it often makes sense to think about breaking the task down using multiple, more specialized agents. Keeps things manageable.
Right. Don't give one agent too many different kinds of hands. Gets confusing. Right. The third leg of our stool, instructions. This sounds like it's all about telling the agent what we want it to do, how to behave.
Exactly right. Clear, well-structured instructions are absolutely critical, especially for these autonomous agents. They minimize ambiguity, improve the agent's decision-making, which leads to smoother workflows, fewer mistakes.
So what are some best practices here? How do you write effective instructions for an agent?
Well, one really good starting point is to leverage any existing documentation you already have.
Like SOPs or help docs?
Yeah, standard operating procedures, support scripts, policy documents, fantastic source material for creating routines an agent can follow. Like in customer service, a routine might map directly to a specific knowledge base article.
Okay.
It's also really helpful to instruct the agent to break down complex tasks into smaller, more manageable steps. Reduces the chance the model gets, lost or makes wrong assumptions.
Makes sense. Chunk it down. Any other key tips for crafting good instructions?
Yes, definitely. Make sure each step corresponds to a clear action with a specific expected outcome.
Be specific.
Very specific. Instead of just saying get customer info, you might specify ask the user for their order number and confirm their email address, or maybe call the customer details API endpoint to get their account info. Being explicit about the action, even the wording sometimes, leaves less room for error. And also, super important, think about edge cases, those unexpected things that always crop up.
Oh yeah, the curveballs.
Exactly. Your robust set of instructions anticipates common variations and tells the agent how to handle them. Maybe alternative steps if some info is missing, for instance.
That's really proactive, almost like pre-troubleshooting.
Precisely. And what's really becoming powerful now is using advanced LLMs themselves to help generate these instructions from your existing docs.
Using AI to write instructions for AI.
Yeah. You can prompt a model, basically ask it to act like an expert instruction writer, say, take this Help Center article and turn it into a numbered list of clear, unambiguous steps for another agent. It's a great way to get started, save some time.
That's a clever way to bootstrap the whole thing.
I know.
Okay, so we've got our model, our tools, and our instructions all set. Now, how do we actually make these agents execute workflows effectively? That sounds like orchestration, right?
That's right. Orchestration is basically how an agent, or maybe a team of agents, goes about executing a workflow. And while it might be tempting to jump straight to building a super complex, fully autonomous system...
Yeah, go big or go home.
Right. But our experience suggests taking an incremental approach is usually way more successful. Start simple. Add complexity only when you actually identify the need for it.
Start small, grow smart.
Okay.
So what are the main ways we can orchestrate these agents?
Generally, orchestration patterns fall into two main camps: single-agent systems and multi-agent systems.
Right.
In a single-agent system, you've got one model with all the tools and instructions needed to do the whole workflow, usually in some kind of loop.
One agent does it all.
Right. Then, multi-agent systems distribute the work across several coordinated agents. Each handles different parts of the process.
Let's start with single-agent systems then. What does that look like in practice? How does it run?
Think of it as a continuous cycle, or a run. The agent operates until some condition tells it to stop.
Like what?
Could be when it successfully uses a final tool to get the result. Or maybe the model itself gives the answer directly, doesn't need more tools.
Right.
Or if it hits an error it can't fix. Or even if just reaches a max number of attempts, prevents getting stuck in endless loops.
Safety valve.
Exactly. The agent's SDK, for instance, has a runner.run method that manages this whole loop process for you.
So it's like a little self-contained problem-solving unit. You also mentioned prompt templates earlier. How do they help manage complexity in these single-agent setups?
Prompt templates are a really effective way to handle different scenarios without drowning in tons of individual prompts.
Okay.
Instead, you create a single flexible base prompt. It has placeholders, variables for specific info. This template can then adapt just by filling in the relevant details for each specific case. It makes managing and evaluating your prompts way easier because you're dealing with one core template, not dozens. For example, you could have a template for a call center agent. Variables like caller's name, how long they've been a customer, the issue category. New call comes in, you just plug that specific info into the template, boom.
That's a smart way to stay organized, keep it efficient. So when does it become necessary to move beyond one agent? When do you need a multi-agent setup?
Our general advice is really try to push what you can do with one well-designed agent first.
Maximize the single agent.
Right. Because while multiple agents might seem more natural for dividing tasks, it definitely adds complexity, coordination, overhead. Often a single agent with the right tools and clear instructions is enough.
But sometimes it isn't.
Sometimes it isn't. If you find a single agent is consistently struggling with really complex logic, or if it has access to so many tools, gets confused choosing the right one, even with good instructions, that's a strong sign you might need to break the problem down more.
Tool overload.
Yeah, or just logical complexity. As a kind of practical guideline, look at your prompt templates. If they have loads of nested if-then-else conditions, making them super hard to manage, splitting those different logic paths across separate agents can often help performance.
Okay.
And with tools, it's not just the number, but also how similar they are. If you can't make the distinctions clearer with better names or descriptions, maybe multiple agents, each with fewer, more distinct tools, is the answer.
Okay, so if one agent is getting overwhelmed by complexity or just too many tools, maybe it's time to bring in a team. Yeah. Tell us more about these multi-agent systems. What are the common structures?
Yeah, while you can design them in lots of ways, there are two broadly applicable patterns we see a lot: the manager pattern and the decentralized pattern.
Manager and decentralized. Okay, let's start with the manager pattern. What's the core idea there?
In the manager pattern, you have a central manager agent. It oversees a network of more specialized agents.
The boss agent.
Kinda, yeah. The manager usually talks directly to the user, maintains the overall workflow. When it needs a specific subtask done, it delegates. It calls a specialized agent as if it were a tool.
Ah, okay.
Then it gathers the results back and synthesizes a final response for the user. It's really useful for keeping control, ensuring a consistent user experience. The manager is the central point, like a project manager assigning tasks to team members and putting it all together.
Can you give a practical example of how that might work?
Sure. Let's say you have a service that translates text into multiple languages.
Okay.
You could have a manager agent, its job, take the user's text, get it translated into, say, Spanish, French, and Italian.
Right.
This manager agent could then call specialized translation agents, one just for Spanish, one for French, one for Italian, as tools. Each specialist does its translation. The manager collects the results, presents them back to the user as one combined output. And you can see how this fits the agent's SDK. You define the translation agents, then just equip the manager agent with those as available tools. It's worth noting, too, some frameworks get really structured, almost like drawing diagrams for these workflows.
Very rigid.
Yeah. The agent's SDK is more flexible, more code-first, lets developers use normal programming logic to define how the agents interact.
That sounds pretty powerful for controlling complex workflows.
Yeah.
Now, what about the other one, the decentralized pattern? How's that different?
In a decentralized pattern, the agents operate more like peers. No central manager.
Okay.
Instead, these agents can hand off tasks directly to each other based on their specialty. A handoff is basically a one-way transfer of control and the current conversation state.
So it passes everything along.
Exactly. In the agent's SDK, a handoff is treated like a special kind of tool or function. When Agent A calls a handoff function targeting Agent B, the system immediately starts running Agent B, and Agent B gets all the relevant context from Agent A's conversation so far.
So it's more like passing the baton in a relay race.
That's a great analogy, yeah. This pattern is super useful when you don't need one agent overseeing everything or combining the final result. Each specialist can just take over talking to the user when needed.
Where would you use that?
Customer service is a classic example. You might have an initial triage agent first point of contact. Based on the issue, technical problem, sales question, order status. The triage agent hands off the whole conversation to a specialist. Tech support agent, sales assistant, order management agent.
Ropes them to the right expert.
Exactly. Very effective for that kind of routing. And optionally, you can even design it so the second agent can hand back to the first if more routing is needed later.
That makes a lot of sense for streamlining those complex interactions.
Yeah.
Okay, wow. We've covered the foundations, models, tools, instructions, orchestration. Now let's go back to something you flagged earlier that sounds absolutely critical, guardrails. What exactly are they, and why are they so vital for these autonomous agents?
Guardrails are, they're absolutely essential for managing risks, especially around things like data privacy or just protecting your organization's reputation.
Right.
Think of them as layers of safety measures, like multiple lines of defense. No single guardrail catches everything, but combining several specialized ones, that creates much more robust, reliable agents.
You mentioned a layered approach. What kinds of layers are we talking about?
Well, you might have guardrails that use other LLMs to analyze the inputs and outputs of your main agent, looking for harmful stuff or maybe just off-topic content.
Okay, using AI to police AI.
Kind of, yeah. You could also have rules-based guardrails, more deterministic checks, looking for specific keywords, patterns, things like that. And then there are external services like OpenAI's moderation API that add another filtering layer.
So it's a multifaceted defense. What are some specific types of guardrails we might see?
There are several key types people use. A relevance classifier makes sure the agent stays on topic, flags queries outside its scope.
Like asking a flight booking agent about the weather in Paris.
Exactly. The classifier says, nope, not my job. Then there's a safety classifier, detects potentially harmful inputs, attempts to trick the agent, prompt injections, jailbreaks.
Trying to get it to misbehave.
Right. A PII filter helps stop the agent accidentally leaking personally identifiable information. Moderation guardrails flag harmful or inappropriate content, hate speech, harassment. Tool safeguards assess the risk of each tool the agent can use.
Risk ratings for tools.
Yeah, like low, medium, high risk, based on things like, does it read data or write data? Are its actions reversible? What's the potential financial impact? These ratings can then trigger actions, maybe require extra verification for a high-risk tool, or escalate to a human.
Fine.
And finally, you have rules-based protections, input length limits, blocked word lists, and output validation, making sure the agent's responses align with your brand voice and policies.
That sounds like a really comprehensive safety net. How do you even start implementing these effectively? Where do you begin?
We usually recommend starting with the highest potential risks first. Often that's data privacy and content safety. Get those basics covered.
Makes sense.
Then, as you deploy your agent, see real-world use, you'll inevitably find unexpected user behavior, maybe spot vulnerabilities. That's when you add new guardrails to address those specific edge cases you discover.
Learn and adapt.
Exactly. And it's really important to balance security with usability. You don't want guardrails so strict that they stop the agent doing its job well or just frustrate users.
Right, finding that balance.
In the agent's SDK, you can implement guardrails as functions or even as separate agents running alongside the main one. one. Maybe a guardrail function analyzes user sentiment if it detects strong negativity, maybe predicts churn risk. It could trigger an action, like offering proactive support. The SDK often uses optimistic execution. The main agent keeps going while guardrails check in the background. If a guardrail flags something, it interrupts the main process, triggers a response.
That sounds efficient, but still safe. Now, even with all these guardrails, it feels like there might still be times when a human just needs to step in. How do you plan for that?
Planning for human intervention is absolutely critical. It's the ultimate safety net. And it's also a great way to learn and improve the agent, see where it fails. We typically see two main triggers for bringing a human in. First, when the agent hits certain failure thresholds.
Like trying too many times.
Exactly. Maybe it asks the user to rephrase too many times or fails a task repeatedly. If it hits those limits, say, it just can't understand the user, it should escalate to a human.
Okay. And the second trigger?
The second is when the agent is about to perform a high-risk action. Anything sensitive, irreversible, or with big consequences. Canceling an account, authorizing a big refund.
Yeah, you want eyes on that.
Definitely. Those should probably require human review and approval, at least until you're extremely confident in the agent's reliability for those specific high-stakes situations.
That makes perfect sense. Build trust. Have a fallback. Well, this has been fascinating. We've covered a huge amount today, from the basic idea of agents down to the nitty-gritty of design, orchestration, and those vital safety measures.
Indeed. Agents really do represent a significant leap forward in workflow automation. The potential for systems to handle complex, multi-step tasks with real autonomy, it goes way beyond traditional software, even beyond basic LLM integrations.
So just to quickly recap some key takeaways for everyone listening. Agents shine with complex decisions, hard to maintain rules, and unstructured info. Building them effectively means choosing models carefully, defining clear tools, writing precise instructions. We looked at orchestration, single-agent versus multi-agent patterns like manager and decentralized, and crucially, the vital role of guardrails and planning for human intervention to keep these powerful systems reliable and safe.
Exactly, and for anyone listening thinking about how agents might help them, our best advice is usually, start small. Pick a well-defined problem, test with real users, then iterate. Grow the agent's capabilities gradually. It doesn't have to be a massive Big Bang deployment.
Definitely sounds like a journey of exploration and refinement. And on that note, it really makes you think, doesn't it, about the longer-term impact of having these kinds of intelligent, adaptable systems automating more and more complex work. What new possibilities open up as this tech keeps evolving? It's a truly fascinating space to watch. Thanks for taking this deep dive with us today.